Let's look at the connection between the math standards of practice and music. In terms of making sense of problems, mathematically proficient students start by explaining to themselves the meaning of a problem and looking for entry points. They analyze the givens, the constraints, the relationships, the goals. In music, composers use a similar approach in deciding about the form, the harmony, the rhythm, the instrumentation to reach the goals of their creation. Conductors and performers determine the most effective solutions to the challenges presented to deliver the best possible performance. Recording engineers have to consider the physics, acoustics, and technical challenges that must be solved to capture and distribute the highest quality sound. So making sense of problems is common to both mathematics and music. In terms of reasoning abstractly, mathematically proficient students make the sense of quantities and their relationships in problem situations. Music theory and analysis represents a sophisticated level of abstract reasoning with respect to the interplay of harmony, melody, rhythm, and form as it appears across musical examples from various locations, times, and cultures. When it comes to viable arguments, mathematically proficient students are able to compare the effectiveness of two plausible arguments to distinguish the correct logic or reasoning from that which is flawed, and if there is a flaw in the argument, explain what it is. Elementary students can construct arguments using concrete references such as objects, drawings, diagrams, and actions. Comparing different musical performances in terms of how the interplay of harmony, melody, rhythm, and form contribute to their success provides opportunities for strengthening critical thinking through viable arguments. In terms of modeling with mathematics, mathematically proficient students can apply the mathematics they know to solve problems arising in everyday life, society, and the workplace. Musical notation is a system of symbolic logic that models real-life performances. Software systems used in musical composition, recording, and performance model physical properties of both real and imaginary instruments. Using tools strategically, mathematically proficient students consider the available tools when solving a mathematical problem. They're sufficiently familiar with the tools appropriate for their grade or course to make sound decisions about when each of these tools might be helpful, recognizing both the insight to be gained and the limitations. Music provides wide-ranging opportunities for data analysis, from the characteristics of popular music, the technical challenges of digital recording and distribution of music, the economic impacts of music on society, and the geographic origins and influences of music, past, present, and future. All of these give opportunities to use tools strategically. Attending to precision. Mathematically proficient students try to communicate precisely to others. They calculate accurately and efficiently, express numerical answers with a degree of precision appropriate for the problem context. In music, the precision of timing ranges from a 30th of a second in video to a 50,000th of a second in terms of digital recording. Calculating the timing of music and graphic video images demands high precision, as does the accuracy of live performance. In terms of making use of structure, mathematically proficient students look closely to discern a pattern of structure. Understanding structure within music has often provided formative experiences for people who later became mathematicians. Of Einstein, it is said that music stimulated parts of his brain that could not be accessed through sitting at his desk. It gave him a sense of patterns, feelings, hunches, and intuitions, all manner of sensual information that could be described as ways of thinking that don't involve words. The deeper world of musical syntax and structure is akin to the sorts of sophisticated structures, syntax, and regularities that are a part and parcel of mathematical thinking. And regularity in repeated reasoning. Mathematically proficient students notice if calculations are repeated and look for general methods and for shortcuts. Musical composition and notation, digital composition using beat matching, music theory, form and analysis all depend on identifying and using regularity in repeated reasoning. So we'll be exploring all 8 of these standards of mathematical practice and you'll have the opportunity to provide examples of each of them as you progress through these activities.